it is my great honor to introduce to you today Elizabeth Wrigley-Field. Many of you will know her already from her participation in the workshop in Demography or from hanging out at Wisconsin. But her vita is very rich and interesting, and perhaps there are still things in there with which I can surprise you. Dr. Wrigley-Field earned her BA in sociology in 2006 from NYU with no less than 3 minors in philosophy, mathematics, and history. She then continued with that philosophy interest, earning an MA in philosophy in the downright Humean topic of whether statistical associations can reveal causes. The rigorous skepticism that she developed in that MA paper continues throughout her work, as she continues to ask what kinds of inferences can legitimately be drawn from what kinds of statistical regularities. This question, arguably one of the most important in the social sciences, brought Dr. Wrigley-Field to the topic of mortality deceleration. In 2 lovely papers, one published in Demography in 2014, the other in the Vienna Yearbook of Population in 2013, Dr. Wrigley-Field has explored what we can legitimately infer about population heterogeneity from evidence of mortality deceleration and under what kinds of circumstances. Perhaps like many of us, I had previously sort of assumed that mortality deceleration was the clearest and strongest example of the kind of selection that we already understand very well, and that we already know how to model. And so I'm trying to write this book on the epistemology of quantitative social science, and I began my chapter on selection with mortality deceleration. Until I read her 2014 paper, in which case I knew that chapter had to be revised. So this is why it's good to write slowly. Then smart people show you that you're wrong before you put it out in print. So thank you for making my life harder, but also for making my chapter better. So she has won a very wide range of awards and grants and fellowships for her work, notably including a National Science Foundation Fellowship, the Ford Foundation Fellowship, the Clifford Clogg Award, and the Catherine DeCray Lumpkin Dissertation of the Year Award. She's currently a Robert Wood Johnson postdoc, and in 2014 will begin as Assistant Professor of Sociology at the University of Minnesota. With that, it is my great honor and pleasure to present to you Dr. Elizabeth Wrigley-Field.
I'm going to present some work I'm doing jointly with Felix Elbert on what can we learn from old age disparities in mortality, particularly between Black and white Americans. So, among the most fundamental inequalities are inequalities in mortality. And this is partly because what's more important than who lives or dies, but it's also because we think that inequalities in mortality can actually reveal a lot about inequalities that exist while people are still alive, as they age through the life course. So here I'm showing you just a couple of years of life from a cohort of Black and white women in the United States. This is just a couple of years when they're in their early 80s, and it probably won't surprise anyone here that the Black women have higher mortality than the white women. And we think that this makes sense because it reflects the deep disadvantages that African Americans face compared to white Americans. But now look just a few years longer, and you see the death rates cross. For this cohort after age 87, Black women, the red line, have lower mortality than white women. They're less likely to die in any given year. So one question is, what do we conclude from a pattern like this? Should we now decide that suddenly at these very old ages, Black women are in conditions of privilege relative to their white counterparts? Well, that question, it's not just an idle question because it actually arises in a very important, although not as well known, historical context in the work that the economic historian Robert William Fogel did on slavery in the United States. And this is work that really fundamentally reshaped a lot of demographic thinking about a whole range of questions, including questions about mortality declines and nutrition. So this is a graph from Fogel, and here he shows us that at early ages, in infancy and in childhood, he's comparing the mortality of Black slaves to free whites in the antebellum US South. And it is not surprising that Black slaves have vastly higher mortality. The conditions of slavery are not conducive to survival in infancy and childhood. But again, just look a little bit farther out and you see that that disparity disappears, and indeed by age 20 it seems to reverse. So what do we make of this? Do we think that slavery is very unhealthy when you're very young, but after that it doesn't matter much? Well, interestingly, Fogel draws a conclusion from these data that's actually not that dissimilar to that. So he argued on the basis of not just this comparison, but a whole lot of comparisons that have the same structure, that the nutritional deprivation associated with slavery is very important at young ages, but really doesn't matter that much once you reach adolescent years. I don't know about you, but I find that implausible. But luckily, we don't have to follow Fogel to this conclusion from these kinds of things. There is an alternative, and the alternative is mortality selection. So that's what we'll be talking about. And the premise of mortality selection is that all social groups are driven by inequalities. And in very stylized language, we say that some people are frailer and other people are more robust. As a cohort ages, its frailer members die first, and so the survivors are an increasingly robust group. A consequence is that their mortality is lower than it otherwise would have been because the people at the highest risk of dying just aren't there anymore. Now, this language of frail and robust tends to conjure this very biological image of these, sickly, frail people versus strapping, healthy, robust people. But actually, the way I want you to think about this is much broader than that. Frailty represents here the whole assemblage of all of the things that can make somebody more likely to die than somebody else that are pretty stable over the life course. So I'm thinking about things like, did you go to college? Are you discriminated against on a regular basis? What kind of neighborhood do you live in? Does it have clean water? Do you have autonomy at work? Were you low birth weight? All of these kinds of things. So when I say frailty, what I want you to hear is embodied disadvantage. And in particular, these are the disadvantages that are invisible to us as social analysts. They're the inequalities inside the groups we measure. Now here's the key point. All social groups have these inequalities within them. So there are frail and robust blacks, there are frail and robust whites. But not all groups are equally selected by mortality. Disadvantaged groups are selected more quickly because their mortality is higher. So if you live to be 90 years old in the conditions that black women are in this country, that indicates that you had to have something really going for you in order to live so long in a way that is just not required of white women. And a consequence is that when we compare blacks and whites after all of this selection has taken place, we're comparing this very, very select group of blacks to a much broader group of whites. It's an inherently biased comparison. So, this leads us to the problem and the promise of mortality selection. The problem is that these group differences that we observe are conflating two different things. They're conflating what's happening to these people at the moment we're observing them, but they're also they're conflating that with the legacy of these selective differences. It gives us two opposite ways to interpret the same disparities. That's the problem. The promise is that if we're willing to assume that something like the crossover is really an artifact of selection, in other words, if we're willing to say, we just don't believe that slavery doesn't matter to your chances of survival after you reach age 20, or we just don't believe that older black women are in great conditions compared to older white women, so we think this has to be selection, then you might be able to use these artifacts of mortality, these artifacts of selection rather, to reason backwards and understand something about the selection process. So something like the crossover could become very revealing about what were these invisible inequalities, these inequalities that we didn't otherwise manage to measure in our data. There's a long demographic tradition that tries to do this, and so that's our jumping off point today. So very recent work on the crossover has developed a new strategy to try to do this. But there's a deep unacknowledged tension in this work that is what we'll be grappling with. So this work references these theoretical models of mortality selection that involve unidimensional heterogeneity. So people can be more frail or they can be less frail, but that's just one kind of thing about them. But these models are implicitly appealing to a multidimensional conception of heterogeneity. So I'll show you how that works. This work takes as its starting point that we can measure some important dimension of heterogeneity and mortality risk. So sometimes it's poverty, sometimes it's religiosity, it could be anything that's in your data set that you think matters to mortality. We measure one of those, but others are left unmeasured. So the idea is that there's this whole thing called frailty, and we've taken off a piece of it that we can see, but other parts of frailty remain. And the idea is that you could stratify on this observed piece and see what happens to the crossover. When you stratify, does it happen at an older age or a younger age than when you have the population as a whole? So for example, in the poor population, that black-white mortality crossover happens at a much earlier age than it does in the population as a whole. Now the point of this analysis is supposed to be that, according to these papers, this should constitute a test of a selection model in which this observed dimension of heterogeneity is really important. So for example, the conclusion of one of these papers is this shows us that poverty is a really important driver of the black-white mortality crossover.
Can you say that last part again? What shows us that?
The fact that the poor have a crossover at a significantly earlier age than the population aggregated over poverty. So the precondition for this test is that a mortality selection model that has these two dimensions of heterogeneity, the poverty that we observed, the frailty that we didn't observe, it has to make a clear prediction about what will happen to the age at crossover when you stratify. Because if you could stratify on poverty and find the crossover moving to an older age or a younger age, there's not a test there, because no matter what you find, you can't falsify it. If you can't falsify it, there's no test. And so the key premise of this work is that a multidimensional heterogeneity model will make a clear prediction about the order of the crossover when you stratify on part of the heterogeneity. The problem? There is no explicit model in any of this work of the crossover under conditions of multidimensional heterogeneity. And so that's what we provide. So this is going to be a theory talk, partly because I think if there's one thing to take from that Fogel example, it's that our data are blind without a theory to tell us what to make of them, and partly because my read of this recent work is that we're at a point where a theoretical intervention is needed. So I'm going to proceed in 3 steps. First, I'm going to show you the unidimensional selection model that has animated demographic work to date. Then I'm going to give you a new model of the crossover for multidimensional heterogeneity, and I'll show you how it works analytically, but also with simulations. Unfortunately, the upshot of that model is going to be that it doesn't support the kinds of inferences that recent work has been making, so I'll conclude with some thoughts about where does this leave this larger project of trying to use a crossover to understand these invisible inequalities. So starting with the unidimensional model, this is the canonical model animating demographic insight into mortality selection. So in this model, there's 4 kinds of people. You can be black or white, you can be frail or robust, and everybody ages with Gompert's mortality, so their mortality increases exponentially over age. Conditional on frailty, blacks always have higher mortality than whites do. So here's the same equation. This is just pictures to show you what these mortality lines look like. And one thing to notice here is that, I should say these are simulated cohorts because frailty is a theoretical construct, right? So that's going to be true of all the graphs that I'll show you today. And in this picture, being black and being frail, yes?
Do you mean F greater than 1 if correct?
Good question. I mean F greater than 1 for a general model, but F greater than B if I want to show you a crossover.
What is lowercase b?
B is the mortality multiplier on being black. So yes, I should have probably put F greater than 1. That's the general model here. If there's going to be a crossover in it, the condition is that being frail has to matter more than being black does.
Yeah.
The little letters and the big letters are the same thing, is that right?
That's right. So I'm using the big letters here as a binary. It can be the little letter value, or it could just be 1. Like if you're white, your value is 1 instead of B. So, right, so the takeaway from this graph should be that being frail matters a lot more than being black here. So the difference between the colors is much bigger than the difference between the solid and the dashed lines. And that's a precondition for the crossover. So let me actually say a little bit more about that. It's very hard to calibrate what constitutes a large or a small value of these mortality multipliers on something like being frail, because these are theoretical constructs. And not only are they unobserved by assumption, but they're also supposed to represent this amalgam of unobserved traits. So it's like we're imagining, here we have this collection of everything that increases your mortality that's stable about you, but we're imagining that those clump together such that we can think of it as just one kind of, mega disadvantage.
Which has the same effect at all ages? The proportional?
A proportional effect, that's right. So how should we think about this omni disadvantage? What does it mean to be big or small? How much difference should that make to mortality? I don't know. But having given that disclaimer that we really don't know what a big mortality multiplier on frailty would look like, let me just say that in a model like this, you need a big mortality multiplier on frailty in order to get a crossover. So just to give some perspective on that, the classic mortality selection model in heterogeneity's ruses, the way it makes this pretty crossover picture, that this is where for a lot of us our intuitions about the crossover came from, is actually that it just puts a really big interaction term so that being frail matters a lot more for blacks than for whites. Our model here doesn't have any interaction term, and a consequence of that is that the frailty multipliers to get any kind of crossover here are going to be pretty large. So to put this in perspective, when you see in this talk frailty multipliers of like 4, that's about the sex disparity in post-transition Russia at old ages. So this is really about the extreme of what we would think of as a mortality disparity for like single trait demographic groups. So that's just to kind of calibrate. We're talking about big differences here. And I think the upshot of that is not just for this unidimensional model, but for this whole talk, the project that we're engaged in at this moment, I think, is less about trying to find and empirically calibrate a model that would work well for empirical research. And we're really a step behind that, I think, in trying to understand some basic selection dynamics by seeing how they work in this kind of stylized fashion. So that brings us back to the crossover. At the aggregate level, the racial difference in mortality is a trade-off. It's a trade-off between blacks having higher mortality, which we just saw, but blacks having fewer surviving frail members, which is this curve on the left, and that gives us this crossover that you see in this span of ages there between about 60 and 80 on the right. So here's the aggregate racial difference in mortality formally. Again, it's that trade-off. So these two terms on the left in blue, these are the black-white differences in mortality in these frail and robust subpopulations. And then on the right, you have that white-black, that compositional difference in how many of your survivors are frail. And here is the key point. Every single term in this model has known sign. This is what lets us reason qualitatively about how the crossover works. This is why we have intuitions about mortality selection. And this is our jumping off point. So, what happens when we have more than one kind of frailty? So now I want you to imagine a black and white population in which you can be exposed to tobacco in utero or not. And in addition to that, you can also be residually frail or residually robust. And otherwise, this model is just like the one you just saw. So basically, we just split that frailty term up into 2 parts and multiply them together. And the question following the empirical work is, let's say that we observe tobacco exposure, but we don't observe residual frailty, then we condition on tobacco exposure. So we've got these two subpopulations that are defined by whether you are exposed to tobacco. We've got this aggregate population that's aggregated over tobacco. Who's going to reach crossover first, the subpopulation or the aggregate? And what we want to see is a clean prediction. Now, if this were the unidimensional model that we just looked at, we would know two things about frailty. We would know that the frail have higher mortality than the robust, and we would know that white survivors are more likely than black survivors to be frail. So if we reasoned analogously to the two dimensions of heterogeneity in the multidimensional model, we would say, okay, we know that being exposed to tobacco means your mortality is higher than if you weren't exposed. And we also know that white survivors are more likely to be exposed to tobacco than black survivors, right? And then we would say, okay, if in that case, conditioning on tobacco means that we're lowering white mortality relative to black mortality, we're going to push the crossover out to an older age. So we have this predictable order that the crossover should happen first in the aggregate, later in the subpopulations. Does everybody follow that? This is the key.
I'm following one, but I'm not following two. Tobacco exposed.
Because if you're black and exposed to tobacco, you wouldn't survive so long is the idea. Just like if you're frail and black, you wouldn't survive so long.
So,
Are you asserting this is true, or you're just saying
No,
this? Okay,
no.
okay. Okay, fine. You're just
I'm
kind of saying this sounds intuitively like it might be true.
Exactly. This
Okay.
if you think that you could generalize from the unidimensional model to each dimension of heterogeneity in the multidimensional model, then these would be true. Okay. Cool.
so, in a sense, blackness is a multiplier of frailty. This is the idea that
Right, so if you're black and frail,
it's worse than
it's worse.
just black. Right?
Exactly.
In any dimension of frailty, any aspect of frailty.
That's right, either one of them. That's right. Okay, well, as Josh, I think, has guessed, this is assuming that these are true, but in fact, neither generalization needs to be true in the multidimensional model. So why is that? Well, the first one is easy. Do the tobacco exposed always have higher mortality than the non-exposed when there's this other kind of residual frailty? Well, no, they can have a crossover just like blacks and whites can, because if you're exposed to tobacco and you're residually frail, you're probably not going to live so long. And we call that a frailty crossover. Now, the second one, are white survivors necessarily more likely than black survivors to have been exposed to tobacco? Again, not necessarily. And this point is more subtle, but it's also more interesting. I'm going to skip the math unless you want to see it. I'll just give you the verbal intuition here. The idea is this. If tobacco exposure really increases mortality a lot, and then blacks are going to be very heavily selected against tobacco exposure, and the tobacco exposed are going to be very heavily selected against residual frailty. And the interaction of these two facts can mean that blacks are less selected against residual frailty than whites are because they're more selected against tobacco. That's what I just said, and it can be true in reverse as well. So if residual frailty is the thing that matters a lot to mortality, then blacks can be more selected against residual frailty, but because of that, they can be less selected against tobacco and more likely to be tobacco exposed than whites are. So I just want to take a moment to underscore how deeply weird this is if you, like me, are used to thinking about the unidimensional heterogeneity model. Because in that model, the one thing we really know is that white survivors are less likely to be frail than black survivors are. That's the whole point. It's what makes the whole thing go.
Reverse it.
Did I? Thank you. That white survivors are more likely to be frail, right? And that doesn't need to be true. So at that point does not generalize to each individual dimension of heterogeneity in the multidimensional model. Yeah.
Is one way to think about the underlying problem is that we can't see the correlation structure. So under known conditions of correlation structure, you could generate predictions.
Yeah, so the problem is it's these three-way correlations, right?
Yeah.
So you don't know, it makes any two of them unpredictable. So it's right that if you knew any two of them, you could get particulars. That's exactly right. So here's what this looks like in the aggregate mortality. In the form, this is exactly analogous to the unidimensional model we saw. So we have the black-white difference in the mortality of the tobacco exposed. We have the black-white difference in the mortality of the non-exposed. And then we have this compositional difference in how likely you are to be exposed to tobacco, depending if you're black or white. And in the unidimensional model, remember the point is that every term here had a known sign. Here, not one of them does. So the terms on the left, they can take either sign because that's just our black-white crossover in the subpopulations. Right, and this is, right, so, and this is so far so good. The compositional term means that the sign of the aggregate black-white difference can diverge from the signs of the subpopulation differences. Well, that's what we want, right? We want it to diverge in a predictable way because that will tell us whether the subpopulations are going to have a crossover predictably earlier or predictably later than the aggregate. So that compositional term, what we're really hoping for is for that to have a predictable sign. But in fact it doesn't because neither of its components do. So this, this difference between the mortality of whites who are exposed to tobacco or not can take either sign because there can be a frailty crossover or not. And this compositional difference can take either sign because there can be a frailty reversal or not, meaning we don't know in advance, are blacks more likely or are whites more likely to have been exposed to tobacco. So let me go through this with two quick examples. One possibility is the normal case. So it could be the case that tobacco exposure means higher mortality and that whites are more likely to have been exposed to tobacco, and in that case the aggregate will reach a crossover first. But it could also be the case that whites are less likely to have been exposed to tobacco, or it could be the case that being exposed to tobacco is no longer the high mortality group, and that compositional difference could actually be raising black mortality instead of white mortality, pushing the crossover out to a later age. So that's the basic intuition in the unidimensional model here. But I want to tell you, there's actually a sleight of hand in the way that I've made this argument. Because the empirical literature is measuring an event, which is the exact age at which black mortality falls below white mortality. But I've been giving you these equations that are telling you about a state, which is this span of ages in which blacks have lower mortality than whites. And that can be a source of, that can be misleading. So to be clear, it's not a problem that groups that we see that are not crossed might never reach a crossover at all. And that's not a problem because in empirical research, we often call groups like, we often say a group will cross later if we see it not crossing, and we're actually agnostic about whether it ever reaches a crossover or not. We don't know what happens at ages that are older than our data set, and so it's fine to be agnostic about the future in the same kind of way in our reasoning here. But what's a problem here is that we're also agnostic about the past. So it could, in theory, be the case that we see the subpopulations crossed and the aggregate not crossed at a span of ages, but that's because the aggregate crossed earlier but has uncrossed again. And that's the kind of thing that you should be worried about from the argument that I've given you. So I gave you these state-based equations because I think they're really helpful for getting intuition behind the main dynamics. But if I want to rigorously convince you that both of these crossover orders are possible, this is the gap that you should be worried about. And I fill that gap by doing simulations. So I just follow cohorts over age and find that both orders actually are possible. So let me show you a little bit of that. So this simulation work is ongoing. I'm going to show you some of the results so far. I can show you some example cohorts if you like, but what I think is actually more revealing is to look at the patterns in the parameter space as a whole to get a sense of like just how predictable, how sensitive or insensitive are the crossover orders to the parameters here. So this is what the parameter space that I've simulated so far looks like. These are pretty gross differences here, and they're also, these mortality multipliers were designed to find a lot of crossovers. And so that's why the mortality multipliers on being black are very small, at maximum they're 2, and the mortality multipliers on the 2 dimensions of frailty are much, much larger. They go all the way up to 8. That's because I didn't want to simulate a lot of cohorts that never had crossovers at all. And similarly, then I simulate baseline frailty distributions that start with a lot of frail people, because otherwise with the mortality multipliers this high, people just go extinct very quickly.
So just your comment on the big multipliers. Is there also a kind of a region where we get what we would want? One crossover, modest F's and T's, oh, the world is fine a lot of the time, but not all the time? Or can we not say that yet? I mean, I'm thinking, if we think F's and T's are 1.2, 1.4, then maybe things are quite well behaved. No crossover or one crossover.
If they're that small, I mean, then the black mortality multiplier would have to be very, very small in a model like this to get a crossover. And I think what that reflects is that these models with small dimensionality of frailty and binary frailty are just not, they're not very good models for empirical work. I think what they're much better for is just getting intuition about what the selection dynamics are. But you know, I wouldn't be very empirically satisfied with this. I don't think you should be. Does that? Let me show you the simulation results and we'll come back to it. So, okay. So let's look at these baseline values first. It's not a mistake that this is blank. I'm telling you to set up before I add the data. So what I'm going to be showing you here is we're going to be comparing sets of cohorts that have the same baseline frailty distribution, but they have different mortality multipliers. So every dot is going to be one set of those cohorts. And if in those sets, every cohort has an aggregate crossover first, you're going to see a red dot. If every cohort has an aggregate crossover last, you're going to see a blue dot. If it can be either way, you're going to see a purple dot. So what do we find? That's all purple.
Is that because the projector isn't?
I was worried that the colors wouldn't work out. I hope you can see it. It's a very purple set of dots. And in this graph, because there are 3 baseline frailty parameters to make it in a 2-dimensional graph, I had the 2 subpopulations have the same baseline frailty distribution, but it doesn't matter in any way that you look at these 3 parameters together. It's always purple. All right, what about the mortality multipliers? So now we're looking at sets of cohorts that have the same mortality multipliers, but they differ in their baseline frailty distribution. And I'm going to show you one where the black mortality multiplier is 2. And the x-axis here is the multiplier on tobacco, the y-axis is the multiplier on residual frailty. What do we find? Well, this looks more promising, right? We've got purple above the diagonal there, red below. But, can you see the color difference there?
No.
Oh, I'm sorry. Okay, these ones here, basically below the diagonal it's red, and at and above the diagonal it's purple. So it seems better, but these ones down here, where the frailty multiplier is just 2, well, those are red because those subpopulations never have a crossover. The frailty multiplier isn't bigger than the black mortality multiplier. And so that's why the aggregate always crosses first. It's actually the only one that crosses. And these ones up here, this is more interesting. So at these values, we never find in any of these simulations the aggregate crossing last, but we do sometimes find it crossing in between the 2 subpopulations, which wasn't in our legend of red, blue, purple because we're looking at very stylized predictions here. So I think the upshot is that there might be something that you could, there might be some room for some kind of prediction here, but it's going to be pretty circumscribed what it is. So where does this leave us? So we looked at the multidimensional heterogeneity model because we want to be able to learn about real mortality selection processes when we measure one part of frailty and we don't measure the rest of frailty. That's the state that we're typically in real research. And we don't want to be stuck looking at results like Fogel slavery results and just, not having any way to test a model of what these might be telling us. But we found that the multidimensional model behaves very, very differently from unidimensional mortality selection in some key respects. In the unidimensional selection model, mortality selection makes a negative association between being black and being frail. But in the multidimensional model, mortality selection creates these complex three-way associations where you can't predict in advance the sign of the association between any two of the parameters. And while the unidimensional model is thinking about a single crossover, in the multidimensional model, that crossover depends on a complex set of interactions between multiple potential lower-level crossovers. The result is that when you're stratifying on a single dimension of heterogeneity, but another dimension is unobserved, the crossover order can't be predicted unless you're willing to make some strong assumptions about the parameter values. But I think these simulations suggest it's not even clear where to look for what those assumptions really would be. And the strategy that I've critiqued here of conditioning on the age at crossover is part of a larger strategy of trying to use the timing of the onset of these various artifacts of mortality selection to understand something about the selection processes. In other work, like Jenna was mentioning, I've critiqued other artifacts of mortality selection in a similar vein. So one thing that I take from this work as a whole is that I'm increasingly skeptical about the idea that we can use the age of onset of these mortality artifacts to reason backward about the selection processes and learn something about the invisible inequalities. But I think you guys should actually be really reluctant to follow me to that conclusion because we don't want to be in the state of affairs, right, where we see something like a crossover or like Fogel's results and we don't know whether to say that's because slavery doesn't matter when you're older or that's because of mortality selection. We want to be able to formulate mortality selection models that we could actually test. So that is not a call to give up. These results show us that we can't just import the insights of a unidimensional mortality selection model into a multidimensional context. It doesn't mean that there's no predictions to be found, but it does suggest to me that we need a lot more theorizing to figure out where to look for what they might be. And one way we might think about this is that the demographic approach to mortality selection has been a very backward-looking affair. This is partly because it arose in the era of severe data limitations. But what we do is we take these old age mortality patterns and we reason backwards to say, well, if this is what we see at very old ages, who would have to be missing from the cohort to give us this pattern? And one way to proceed is to use better data to look forward and give a much more direct answer to who's missing from cohorts. So Zayakova and Burgard do this with the Health and Retirement Survey. They look at the respondents as they age in the survey and show that the people who survive as the survey goes on were people who were much richer and much healthier at the beginning of the survey than the ones who die. You can imagine doing that in a lot more data sets, and that's going to tell us something. But when we do that, unless the results that we're looking for are purely descriptive, like unless we literally just want to know who's not there anymore, but if we want to know something about why are they not there, how do we interpret this, we're still going to have the multidimensional heterogeneity problems that we saw here. Because even the best data sets, and the HRS is a very, very good one, they're going to leave a lot of dimensions of real risk and mortality unobserved. And so we are still going to have to think about when we see some people dying more than others, how do we interpret that in light of the potential interaction with the inequalities that we didn't observe? I think we could start to envision developing models that interact with data like this to be more realistic But that brings me to just a final point about the intellectual history of this kind of work, which is that I started out by telling you that there's this disconnect between the theoretical work on mortality selection and the empirical work that people are doing with these Aggregate Crossover models. And I think that that disconnect reflects a larger pattern in the intellectual history of demography. So a generation or two ago, I think of demography as this very intellectually distinctive tradition that was defined by these very precise population models of population dynamics and these really creative efforts to understand a lot about population processes in the absence often of very rich data sets. And I think the classical mortality selection model that we started with is one of the great contributions of this tradition because it taught us to really think critically about what disparities that we observe are telling us. So in recent years, demography has become a much broader population studies. We have richer data sets, we've learned a lot more about social stratification from a broader engagement with the social sciences. So it doesn't make sense to restrict ourselves to these arid models when we know that social stratification doesn't work that way. It's complex, it's intersectional. But in some ways, I think this broader outward engagement with other fields has come without a lot of engagement with the formal demographic tradition. And to me, there's no clearer example of that than work on the crossover that is imagining multiple dimensions of heterogeneity, but never writes down a multidimensional heterogeneity model to see if the assumptions are actually borne out. So part of the motivating vision for me of this work was to say, well, what would happen if you tried to bring those two traditions together and make our formal models just that one step closer to substantive realism? Unfortunately, I think the upshot from this piece of the work, at least, is sobering. It's that when we do that, we might find that some of the things that we've been doing don't reveal as much as we thought that they did. So that's where we're at with this work so far, and thank you very much for your time.
An alternative approach to the one you're taking is the one that Tully Yashin and others have pursued, in which they make parametric assumptions about the form of the baseline hazard and then treat the factors that you're treating as fixed and random effects in a proportional hazard model, and then use maximum likelihood to estimate the parameters of the fixed and random effects, and then, having generated parameter estimates, go back and talk about crossovers. The objection that is often raised to Anatoly, and processes and files it somewhere, the objection is that these proportional models make a very strong assumption about biomedical realities. For instance, in the case you're looking at, that the buildup of tar in the lungs and what that does to your lung cancer survival is totally different for blacks and whites because the effects multiply. If you have a much higher background mortality for blacks for all kinds of stressors and discrimination and problems, then that completely transforms the cancer process because those two things multiply. So the effect of smoking is many times greater. And we can think of reasons why it might be somewhat greater, but that you should hang on to a multiplicative model in that context that carries some claims about the way the human body works. And your approach and the Yashin approach both share that feature. So I wonder if you could talk a little bit of contrasting what you're doing with the tons of papers that come out of the Yashin group, but also address that substantive question about whether this is a place where the proportionality assumption is carrying us into trouble, or can it be maintained?
I think that is a good critique of these kind of models. In this context, I wanted to use models that were very constrained, even if that made them unrealistic. Like, I wanted to have blacks and whites be as similar as possible. So same frailty distribution, same consequences of being frail, because the theory building purpose here is to see, even under those assumptions, how complicated can the selection dynamics turn out to be, even when the starting assumptions are very simple. But I think it's really true that in a real empirical context, it's not at all clear that the proportional hazards assumptions are reasonable ones, and that adds a different layer of complexity to thinking about something like the crossover.
First of all, I very much enjoyed your concluding remarks about how the kind of whole enterprise fits together. And I think it's important to build these models from both directions. I was wondering if you could just go back to your first crossover picture and describe now how we're supposed to think about this, just a simple example, how we're supposed to think about this crossover now with one kind of heterogeneity or multiple heterogeneities. That's kind of what I was missing from.
I see.
After your talk, am I supposed to think, oh, wait a second, I shouldn't go the direction of modeling multiple processes because it's so undetermined, and so I should just think of there being one latent dimension here, and then the world is simple again? Or how do you now think about this picture after your talk?
So I still think that mortality selection is the most plausible explanation for the crossover. I think it's the most plausible explanation for Vogel's results. To me, the alternatives don't make sense. So my starting point is that I think that there's some kind of mortality selection process going on. But I would like to be able to test that instead of conjecturing it, and I would like to be able to say, what is this frailty consistent? And the results that I'm taking from this is that it's not clear to me how we can actually do that, because I think there's good reasons why it seems like a very promising strategy to say, well, fine, we don't know everything that frailty is, but let's just take a piece of it and see what happens. But it turns out that the results are not at all easy to interpret in terms of what they actually tell us about the underlying selection model. So it's not a very satisfying answer, but where I'm at, I guess, is like, I don't think we should give up on mortality selection theory, but I think we should be a lot more humble about our ability to gauge empirically whether that's really what's going on.
My second question was, most of our talks we see regression tables with stars and their omitted variables. And there's some underlying variance covariance matrix of all these things, which is determining whether what we left out matters and all that sort of thing. Is this essentially the same story? Just picking up on Jenna's question on the variance covariance. If we knew all of that, then we would have a clean answer. It's just that we don't know that variance covariance structure.
That's right, but so what I was hoping for is that then there would be some easy qualitative assumptions that we could make, where we could sort of localize that parameter space and say, okay, maybe anything could happen in general, but if we know that if we're in this kind of region, we'll get this kind of thing, because then it becomes reasonable to theorize, broadly speaking, what kind of world do I think we're in, how big is the risk of being exposed to tobacco relative to these other kind of risks. And that's why, to me, the most sobering part is that those parameter values seem to predict so little in the simulations.
So I think that's very clever work. My comments would be that I'm not sure that the racial differential is the best example, because I've read some very convincing research by Princeton in particular, and also by the Social Security Administration, that suggests that much of this crossover is actually due to data quality issues. And Princeton, for instance, I think he mentions that for these cohorts, who are now reaching their 80s, 40 to 50% of the black population is actually missing a birth certificate, And so there is a high suspicion of age overstatement, which would create that kind of crossover.
Yeah, that's been a very important critique of the early empirical work on the crossover, and I think because of Preston and ELO in particular, because of the work they did on that, we know so many problems with census data. I don't think it's the entire explanation for the crossover, for a few different reasons. The example I'm showing you here, this is a cohort that's actually from Medicare data, and these are people that had to verify their age at the time that they enrolled in Social Security. So it's a much more rigorously verified set of ages than in the census work that Preston.
It also introduces a selection, right? That's also another form of selection.
It's less than you would think. It's something like 97% of elderly Black and white Americans are enrolled in Medicare. So it's selection, but it's on a really small
But
scale.
is that consistent with 40% of elderly Blacks not having birth certificates?
I think that when they made people verify, they had a range of ways that people could do it for those cohorts that didn't all have birth certificates. There's a lot of work that's checking these data by people like Bert Kestenbaum, and they're considered to be very reliable. So this is empirical work that I did, and you see the crossover very, very regularly across cohorts, and so I really think that this is real. But the general point about age misreporting is well taken.
An alternative to the point of view you're putting forward, again, seems to come largely out of North Carolina and its various universities, is to emphasize the importance of social connectedness to coping with stress, to all kinds of intermediate causes of mortality outcomes. And indeed, Homer, in a famous piece of work, showed that the variable which asked how often you attend religious service was a stronger predictor of mortality in one of the early national mortality study data sets than was being Black or white. And did not ascribe this to the power of prayer. Some have done so. He ascribed it to being an index of social connectedness, of having a social support system. And African American women of the ages which are studying there often are very much involved in churches or religious observance and with a support system in their communities. So I can see the people from North Carolina saying, well, maybe that's not just selection, but maybe we're also seeing a period in which that social connectedness, which seems to affect health outcomes all through life, maybe that's paying off too. Do you sort of go along with them saying, well, maybe some of one and some of the other, or do you think they're probably exaggerating that? Where do you feel in that alternative hypothesis?
I really agree with what I take to be your larger point, which is that, okay, so I don't think that something like religiosity or social connectedness explains this whole crossover. To me, it's not plausible that given how deep the disadvantages are for Blacks in this country, the neighborhoods people live in, the levels of poverty, everything, it's not plausible to me that there's a real reversal in the disadvantage at old age. But it is completely plausible to me that those disadvantages are much smaller at older ages than at younger ages, partly because of social connectedness differences, partly because everybody having Medicare may actually really matter. So I really do think that one reason why we want to be able to test mortality selection models is that we want to be able to admit the idea that there could be these different things going on, and there could be a real reduction in disadvantage at old ages that interacts with the selection to produce these kind of results. Again, it's not at all clear, we can theorize that people have different priors about what's possible, but it's not clear to me how to actually know.
I'm curious if we actually have to have a crossover to have an interesting effect here. If these lines were further apart, a narrowing of the difference would actually be a larger effect.
That's right.
And yet there's something compelling about seeing them cross over.
Yeah,
That's
it's
important.
dramatic, yeah.
But is this essential to the way?
No,
you
it's
think?
not. This is exactly right. So a place where there is a narrowing but not a crossover is in SES differences instead of racial differences. And there's a very similar discussion there about how much of this is selection, how much is that you can only, is that education can only buy out so much disadvantage before aging affects everybody.
But then you don't have to, without a discrete, sorry, now you have even more indeterminates.
Mark?
So your conclusion, your sobering conclusion, the light of hope is that, one light of hope is the much better new data we have, and so that this might help us out of the problem we've identified. And I'm wondering, when you look at the new data that do exist, what deficits do you still see that we could go further to fix?
Do you mean,
To fix for, that would, to facilitate moving forward with the agenda that you have here. So what are the, so the data we have now are better than the ones in the past, but are they still missing something that we really need, that we really need?
everybody has their different pet theories, right, about like what's the thing that's really gonna matter in data. One thing I could imagine doing is just looking in these data sets that have all different kinds of stuff in them and trying to get a sense of, if you put a lot of these disadvantages together, how big of these combined differences do you get? And that might help you start to bound, like how should we think about these theoretical amalgams like frailty in a way that is more grounded in realism than we're at right now. So that's where I can imagine them being helpful. I feel like every week, like if you just read the news, there's a different article saying, this is the real key to health, and we're never going to have data sets that have all these different things together. So that's the sense in which I meant that, like even something fantastic like the HRS or the WLS, which has just such extensive health measures, but if you think about all the things that, if you think about your own life or the life of your friends, all the things that seem like they end up mattering to health, so much of that is just never going to be captured in a data set. So that's where I'm coming from. I'll take you and then.
But to build on that idea, and to tie it back here, the medical diagnosis, there are certain medical diagnoses, and it's not tobacco in utero, it's tobacco is one that is a very strong predictor of mortality, and now the diagnosis, we can't track people's diets, but if you have diagnoses showing up diabetes, that likely is a widespread and strong predictor of mortality. So part of the frailty is not frailty from in utero, it's frailty that's acquired through environmental exposures and infectious illness. And so the practical implications of your modeling in terms of two determinants, two factors or multiple factors, what we really might want to know is what's the differential, how do differentials in mortality then sort and then change our abilities to accurately estimate mortality rates of older ages, because you've got to get the conditioning right on who's surviving as a result of these early exposures. And it's right that the newspapers are full of things that could hurt you, but we already know some things that do hurt you really, really substantially. So for example, in the slavery example, I look at this and I think, goodness, the huge, huge differential in infant mortality. What about mentally attributing that to diarrheal disease and simple exposure, not having, totally inadequate housing and totally inadequate access to water might have culled, I hate to use that word, but basically led to very much higher mortality. And then what you've got is a remarkable convergence of mortality in childhood and adolescence, which if you had appropriately controlled for the robustness of your children, might then you say are other factors nutritional disadvantage, and in fact spikes should be much bigger because of the conditions. So as a practical application, you might want to actually think about what the real drivers might be, the biggest ones.
I appreciate that. I think that is a good suggestion. The reason why I use tobacco in utero is precisely because it is fixed. Because if we want mortality selection to explain things, it has to be operating at all these different ages,
Yeah,
right?
your
And I
simple
think-
model required that.
Right, exactly, and I think it is, in real work, it's a question that we have to grapple with, that many disadvantages are not fixed, they are acquired and lost throughout the life course. That makes selection a much more complicated beast. Now, maybe we think that the people who acquire those disadvantages, that there's something about them that is stable. And so, if we think that's right, then, there's something that predisposed them to be the ones who would take up smoking, or the ones.
Or if you take as your starting point age 30, and you look at the diagnoses that they've acquired prior to age 30 as being their frailty or not. I mean, if you smoke it, by the time if you smoked, either you're going to continue or not, but you've done a lot of damage already. But I don't know, just
Right, so you're imagining, right, so we could start at a very early
Or
age
even
and
50.
say these are the components, right?
No, I'm saying when the mortality becomes to really diverge.
Right, yeah, that's similar to what the Zayek and Brugger paper does. I think it is a good approach.
I think we have time for one more question.
So, we know that the racial differentials or between black and white have declined in the US. What impact is that going to have on the crossover? Do you see anything in the data?
Yeah, the age of crossover has moved outward over cohorts, and this makes some intuitive sense if we think that the excess selection of blacks has diminished over time relative to whites.
So that would suggest that declining differential is core specific. If that pushes the age further back, that would suggest
Right,
that
so-
older cohorts have not benefited from this.
Cohort specific.
Right, so older cohorts had a bigger difference in early life mortality between blacks and whites, and those cohorts also have black-white crossover at a much earlier age.
And do you see, yeah.
And that is what we're finding today.
Well, it is a delight for us in this room to see proper classical demography, and particularly when combined with such a fine theoretical mind. So thank you very much.
Thank you.